Let's see here. Let's do one more on this page. So number 2. Okay, one more on this page. If we look at our point, here's this x. Notice how it's in there all by itself. So the fact that it's in there all by itself means the x coordinate is a 0. There's no x minus 2 like this one had. Now that -1 is on the backside of the absolute value bars, so that's the y coordinate. So 0, -1 is our vertex. The number in front of our absolute value bars right here is a 1. So that means we want a slope of a +1 and a -1 from that point. Also, make sure we connect these. Some of you on that quiz just threw the dots in. Okay, these should be continuous. So make sure those are all getting connected. All right, and then from there, we do our piecewise function. So again, we know both slopes are 1, so we're going to do -1 and then 1. Our x coordinate is a 0, so it's up to you. I'm going to do it just so we understand that the x coordinate was a 0, but you don't necessarily need to put the 0 in there. It's just an x. And then our y coordinates were -2. I'm sorry, -1. Try that again. All right, and then from there, we go ahead and write our domains. So here's this point. Anywhere to the left of here was less than or equal to the 0, and then anywhere to the right of that would have been greater than 0. All right. All right, so let me see here. What we got? Yeah, let's do one more. Let's do one with a slope of 2. So number 3. All right, so if we look at our point, x minus 1 means our x coordinate is a 1, and then the -3 at the end means our y coordinate is a -3. So we're going to plot that point, 1, -3. Show up good for you, does it, in here? All right, then from that point, our slope is 2. So we're going to go up 2, right 1, up 2, right 1, up 2, right 1. And then the other one, up to the left 1. And this we're pretty good at, really. When we did that quiz where we had to graph these, this was pretty good. From there, go through, write your piecewise function. So we know we have a -2 and a +2 as our slopes. And then now it's just a matter of writing our point correctly. So if our point has an x coordinate of 1 here, that means we come down here and we do x minus 1, x minus 1. And then our y coordinate, was a -3 before I crossed it out. So we should have -3, oh boy, -3. Domain for this one, this guy has an x coordinate of 1 right here. So on the left side, it's all x values that are less than 1. And on the right-hand side, all x values greater than 1. All right. Okay, that hopefully we're pretty good with. I want to do one with a fraction. So let's do one of these here. Yeah, let's do 5. Because I don't think I gave negatives. I want to do a negative. All right, so number 5. If we're going to graph this, if we ask you what point you're dealing with here, there's nothing paired up with the x inside of the absolute value bracket. So our x coordinate is a 0. And then that y coordinate is a -3. All right, now that our slope is a fraction, it's the same thing. It's a +1/2, so we're going to go up 1, right 2, up 1, right 2, and on the left side, we're going to go up 1, left 2, up 1, left 2. So if you remember, if this is less than 1 with our parabolas, remember how it made our parabola wider? It's the same thing with these V-shaped curves, these absolute value curves. It's a wider graph now. Our slope over here was the positive 1/2. Our slope here is a negative 1/2. So when we go to write our piecewise function, the left side has that slope, the right-hand side has this slope, negative 1/2, positive 1/2. If we then use the point 0, both of these would be x minus 0. And if we use the y coordinate of a negative 3, minus 3, minus 3, since this vertex has the x coordinate of 0, anywhere to the left over here is less than or equal to the 0, and then anywhere we have this positive 1/2 slope are all x values greater than 0. All right. Okay. What I want you to do in the next one, though, since we didn't give you one of these, I'd like you to see one of these. Go to number 6 and change it just slightly. Make this a negative 1/3, just to make sure we see one of these. Because I did this to you on your quiz. You will probably see this on the test Wednesday, so I just want to make sure we can do that. So the point doesn't change. That should still just look inside of here with the x. Our x coordinate has to be a positive 1. The negative 2 on the backside means our y coordinate is a negative 2. So that first step doesn't change. So 1, negative 2. All right, now go through and graph this and see what we think. All right. As you're doing it, just keeping in mind, should be pretty obvious because we had to change it to make it this, but we made this now a negative 1/3. So what we have to know is this thing should be opening downwards. So when we count off our slopes of negative 1/3 and 1/3, we have to do so in a way that's going to produce a V that goes downwards. So going up at all is not good. But if I go, this is a vertical change of 1, vertical change of 1. So if I go down 1, which I need to do if I'm going to have a V going downwards, if I go down 1, then we're going to go right 1, 2, 3. Down 1, 1, 2, 3. That is the right-hand side of our V. And then to the other side, instead of going down 1, right 3, we would go down 1 and then left 1, 2, 3. Down 1, 1, 2, 3. Connect those, and then now we have our V that's going to be opening downwards. Okay. What you now need to be very, very careful of is, let's go to write this piecewise function. This vertex occurs at this x value of 1. So actually, let's do our domain first, because we go left to right. So all x values less than 1, greater than 1. But now pay attention. When we're less than 1, so here's 1. Isn't this where we're less than a 1? So now that's where our slope is the positive 1/3, because that's the one that's going upwards. And when we are less than 1 over here, or I'm sorry, greater than 1, which is what this one is, that's when where our line is going to go downwards. So that's why our slope there is a negative 1. Well, hello there, Ella. Right on time. Right on time. Thank you, ma'am. And then we use this point. What was that? 0.1, negative 2. That doesn't change. So we still have x minus 1, negative 2, and then x minus 1 with a negative 2, and then that's our function. Okay, so definitely be able to do fractions, definitely be able to do negative coefficients to know if we're going up and if we're going down. All right, this is page 28, I think, around Ella. Oh, 31. That was close. Just a few off there. A few off. All right. So then, let's go through these guys because this we haven't done in a while. So if I give you a piecewise function and then I just ask you to find some different values, first, let's make sure of one thing. Actually, let's do these first. I want you to do these two problems first so we understand the difference in how these are written. All right. Actually, let's not do those first because we're going to use the graph for this one. Let's just go in order. Find f of 5. So see if you remember how to do that. So if I give you this piecewise function up here, and I ask you to find the functional value when x is 5, see what you think. All right, what should be happening if our x coordinate is 5, which is what this notation means, then we have to look at all 4 of these intervals here and identify where does this get defined. So you have a 5 right here, but notice how there was no equal to, so we wouldn't want to use this one, even though it might give you the same thing. Where x equals 5 is defined is right here. Here's where it says x is equal to 5. So in order for us to evaluate this, we're going to take 5, we're plugging it in for this x. So instead of a negative x plus 13, since that's the function to use for 5, we're going to get rid of the x, and we're replacing it with a 5. So you should get a negative 5 plus 13, so that has a functional value of 8. Okay. Same thing with f of negative 4, same thought process. Where does x equal a negative 4 get defined at? So as we look through these 4 options, negative 4 should fit in between a negative 9 and a negative 3. So to find f of negative 4, we're using this function, the x plus 5. The x in this case is the negative 4. Add that up. That should have a value of 1. All right. All right, do f of 0. That should be easy. Now, we've done a few of these. So do f of 0 real quick. All right, and what we should find, the 0 fits in this window. So you're going to take a 0, plug it in right there. So we would have negative 1/3, multiply the x as a 0, add a 1. So this is all just one big fat 0 plus a 1. So that should also give you a value of 1. All right. Now, this one's a little bit harder. We don't really want to do this one probably until we have the graph. So we're going to hold off on that. That's why I actually kind of went back on what I said initially. So let's go ahead and graph this piecewise function. And then we will be able to identify when f of x equals 0, what x value does that occur at. Okay? All right, so here's how we would graph these. And there's a few different ways that we have done this. So one of the ways is to, let's just focus on this right here, this first one. We could go to 5. So what is that? X equals 5, or x plus 5. So there's a y-intercept of 5. So 1, 2, 3, 4, 5, with a slope of 1. But notice why this is, it's not necessarily wrong, and actually we're going to do it. But we don't want this entire line, right? We don't want all of this. So this has a y-intercept of 5 and a slope of up 1, right 1. And that's what this is telling us we should have. So our y-intercept is 5, our slope is a 1. But notice, we only want this from a negative 9 to a negative 3. So if we go to the x-axis, here's negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to go from here over to a negative 3. So negative 8, negative 7, negative 6, negative 5, negative 4, negative 3. So what that would mean is we don't want anything over here. So we only want that line from the x value of a negative 9 to the x value of a negative 3. All right. Now, the next line, a couple different routes we could take, and we've done them both ways, is we could just now figure out what is f of negative 3. So take our negative 3 and plug that in. So negative 1/3 times a negative 3 plus a 1 should be 1 plus 1. So that's a value of 2. Notice how that is the exact same point we are already at. And then all we now need to do from there is just count this slope off, right? So from that point, that's our starting point for this new one. Count that slope. So from that point, we're going to go down 1, right 3. So from this point, we're going to go down 1, right 1, 2, 3. Down 1, right 1, 2, 3. But again, notice we probably don't want all of this, correct? So that's why I'm not going to connect those right now, but those are our dots. We only want those dots until we hit the x. So we started here. We only want to go to the x value of a positive 3. So if I come back down here, here's the x value of 1, here's the x value of 2, here's the x value of 3. So I now want to get rid of these points over here, and I only want this line until we hit the x value of 3. All right, and real quick, because we're getting a little tight on time here. The next point, just count this slope off. So if we go from this next point, now count off a slope of 4. So from this point, go up 4, 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. Don't necessarily connect them yet because we want to see if it fits in our window. That we go to 5. So if we notice, here was 4, here was 5. You're going to connect these guys. That gets us to 5. And then we've got one more piece. So now that gets us to this point, this line. Our slope from there is going to be a negative 1. So from that point, go down 1, right 1. Wrong thing. Down 1, right 1, down 1, right 1. And then that wanted us to go to the x value of 9. So here's 6, 7, 8, 9. So we would stop right here, connect those, and then that's our graph. I will not have you do 4 of these, I promise. Probably 3 at the most. But yeah, that's what we're going to do. And we'll probably have to talk about horizontal lines as well. I wish there was a horizontal line in there. But that's how we would graph that. Okay. Now, tomorrow we're going to do those equations that we did a little quiz on Friday. That's what we're going to spend most of our time on tomorrow. That will probably be a supplemental little worksheet that I have made up. I'll post that on Canvas. If you're here, I'll just print it for you guys. But you'll have to probably get that on your own because we didn't have any of these in the little review that we have made up. And that'll definitely be on our test Wednesday. All right. Okay. With that, we're going to stop there. We got less. Oh, yeah, Kim. Oh, yeah, thank you. We never did answer that question, did we? Yeah, so let's go back to this real quick. Uh-oh, now it's not responding. We never asked when did f of x equal 0. There's actually 2 answers. If this will ever, there we go. So this is just saying, oh, come on. When did our y value equal 0? We get y values of 0 on the, so here's 3, 2, 1, 0. Here is when our y value is 0. So notice how that graph hits this line 2 different times. One is at the negative 4, and then it also would have hit at this dot right here at a positive 3. So at negative 4 and positive 3, those would be our two, or is that -5? That might be a -5. Yeah, so -5 and +3. Is that what you said? -5? Okay, you guys heard the bell. Take off. We'll see you on Monday, or see you tomorrow. I know you came, but we've had what, 3 to 4 in here?
Yeah, fishing is back up.
Yeah. Oh yeah, Becca. But Nico's been here recently.
Have a good
I
day.
don't know. Bye, Alice. We're supposed to have. Yeah, that might be it.
Trials were Friday and Saturday. Practice, first practice. And our first
Oh, yeah.
game